Good day. For today's video, lesson 6.2, we will be moving on to one-step equations. Our essential question is, how do you use one-step equations with rational coefficients to solve problems? We have two vocabulary terms for today's video, coefficient and equation. Coefficient, that's a term we've used in class a lot, that is the number that is multiplied by the variable in an algebraic expression. And then an equation, which is what we are focusing on today, is a mathematical sentence that shows that two expressions are equivalent. So looking in example 1, we see this equation here. So we see that the left side of my equal sign is equal to the right side. So x plus 3.2 is equal to negative 8.5. So how I solve this is I use inverse operations. And we've used this term in class a lot. The inverse operation implies the opposite. So I have to take a close look at what operation is used in my equation. So in this case, it is addition. So I need to do the inverse of addition, which is subtraction, to get rid of the 3.2 on the left side. So I'm going to subtract 3.2. So all I am left with is x. And since I subtracted 3.2 on the left side, I need to subtract 3.2 on the right. So my problem is negative 8.5 minus 3.2. And because I am already starting with a negative, I'm really just increasing my negatives. So my answer is x equals negative 11.7. And we can check this by substituting our value, which is now negative 11.7, in place of x. So we have negative 11.7 plus 3.2, and if that is in fact equal to the negative 8.5, then we have solved this correctly. Our next example that we're going to look at is involving fractions. So here we have negative 2/3 plus y is equal to 8. So again, I'm going to use inverse operations to solve this. So I need to get y by itself. That's called isolating the variable. So I need to get rid of a negative 2/3. So the only thing that can cancel out a negative 2/3 is its opposite, which is a positive 2/3, which is adding 2/3. So all I am left with is y on the left side. And since I added 2/3 on the left, I need to add 2/3 on the right. So 8 plus 2/3 is 8 2/3. And again, if I were to check this by substituting my value in place of my variable, my problem would be negative 2/3 plus a positive 8 2/3, and which would in fact equal a positive 8. Now, for examples 2 and 3, we have some story problems. So we're going to first need to decipher through the story problem and then write an equation to represent the problem. Example 2. Amy has some money in her checking account. If she writes a check for $42.50, her checking account will be overdrawn by $23.75. How much money is in Amy's checking account now? So first we need to start by writing an equation, to represent this problem. So we know that she has some money, but we don't know how much money she has in her account. So that's where we represent with a variable. So we're going to use x to represent the amount that she has in her account. So with this money in her account, it says that she writes a check for $42.50. So we need to think, well, what does writing a check for $42.50 represent? Is that money being taken out of her account or being put into her account? And writing a check is a withdrawal, so we are subtracting $42.50. And when she does that, her balance is overdrawn by $23.75, which means she's in the hole or she owes the bank that. So that is a negative 23.75. So now to solve this, I have to use the inverse operation. So in my equation, I'm using subtraction, x minus 4250. So to solve it, I need to add 4250 so that I have just my variable x, and what I'm doing to the left side where I'm adding 4250, I need to do that to the right side as well. So I have a negative 2375 plus 4250. So x is equal to a positive 1875. And again, if we were to check it, if we had 1875 minus 4250, you would get negative 2375 for your answer. Moving on to example 3. Now we're going to write an equation using multiplication and or division for this story problem. Tyler received a notice from his bank that the balance in his checking account was negative $12, not zero as he expected. He realized that he forgot to record the time when he used his debit card to buy bus tokens for $1.50 each. How many bus tokens did Tyler buy? So we're going to use the variable t to represent how many tokens he bought. So we know that one token costs $1.50. So if we want to figure out how many he bought, or if we know how many he bought, we would just multiply the number that he bought times the cost of 1, and we know that whatever amount that he bought, it equaled negative $12. And we're going to represent $1.50 with a negative because it is money that is being taken away from him. So, again, using inverse operations to solve. This equation here is negative $1.50 times t, the number of bus tokens, which equals negative 12. So the inverse of multiplication is division. So I'm going to divide by $1.50 so that I just have t left on the left side. And then I'm going to do the same on the right, where I divide by the same thing, a negative 150. So we already know, looking at this problem, we already know that I have a negative divided by a negative, so we know that the answer is positive. So now I'm going to take 12 divided by $1.50. So I need to move my decimal point, 150 does not go into 120, but it goes into 1,200 8 times. And because the decimal point is right here, it is just 8 as the whole number. So t is equal to 8. So fitting back into this problem, we can see that he bought 8 bus tokens. And we can again check it by substituting our value in place of our variable. So if we were to take negative 150 times 8, we would get a negative 12. Now what I would like you to do is on the back of this, try the Your Turn questions on your own. And again, and as always, if you have any questions, we will talk about them tomorrow in class.